The following service information is brought to you by the Alco Controls Division of Emerson Electric. The typical air conditioning or refrigeration circuit will circulate hundreds of pounds of refrigerant every hour. The system will work best if this flow is as unrestricted as system design will allow. The very foundation of all refrigerant system performance is pressure difference. There must be increased pressure at the condenser to make condensation possible and to allow liquid to be fed to the evaporator. At the expansion device, a large drop in pressure makes evaporation possible, and the change in state of the refrigerant from a liquid to a vapor causes heat to be absorbed. The low-pressure gas is returned through the suction line to the compressor, where the process starts all over again. The system that operates best is the system that has pressure reduction where it is needed, and only at these locations. Restrictions that are not in the design of the system will cause loss of performance, inefficiency, and the worst problem of all, increased cost to the user. The fastest way to add unwanted restrictions to any cooling system is to allow contamination to enter the flow path. These contaminants can be metal chips from the installation work, flux, sludge, or wax from a refrigerant breakdown, and water dissolved in the refrigerant. The two components most affected by these contaminants are the expansion valve and the compressor. It is the filter dryers that will help prevent contamination from ever reaching these components. For filter dryers to work best, they must be selected with care. Care in selection of both type and size. The first decision that must be made in the selection of a filter dryer is to choose where the filter dryer will be located in the system. Since the expansion device and the compressor are the components most affected by contamination, it is only logical that a filter dryer be used in these two locations. Typically, a filter dryer is always used before the expansion device, whether it be an expansion valve or other pressure-reducing component. At the compressor, the use of a filter dryer is not quite as certain. But, as we shall see, their use is recommended to help protect the most costly component in the system. The operating port of the expansion valve can be the smallest orifice in the system. It takes very little contamination to cause it to clog and shut off flow to the evaporator. Any contaminant is harmful to an expansion valve, but the one that is least obvious but that can cause the most trouble is water. Any moisture that is dissolved in the refrigerant will condense out as the refrigerant drops in both pressure and temperature at the valve orifice. As the resulting ice crystals collect at the orifice, flow will be reduced. Eventually, flow will stop. Any water that is dissolved in the refrigerant must be removed before the refrigerant gets to the valve. It is the job of the liquid line filter dryer to remove any moisture that entered the system at installation or after the system became operational. Liquid line filter dryers are used in almost every cooling system that uses refrigerant. Since liquid line dryers are built using a different construction than a suction line dryer, the filter dryer selected must come from a liquid line type. The selection made will depend on two requirements: line size and the physical size of the filter dryer itself. It must be understood that, like any other component in a refrigerant circuit, a filter dryer must have adequate rating to match the capacity of the system. That's not quite as easy as it sounds. Most manufacturers will rate their filter dryers to a double set of standards. One set of standards uses laboratory conditions and rates filter dryers based on ideal operating conditions. The second type of rating will rate the filter dryer based on maximizing its performance under field conditions. As a rule, the ratings based on lab testing conditions will be higher than those set by the manufacturer for use under field conditions. When selecting for capacity, the manufacturer's ratings should be used. While these ratings will be lower than the lab-rated version, their use will ensure a filter dryer is big enough to do the job. All filter dryers will follow the rule that the larger they are, the more contamination they will remove. We also know that as a filter dryer goes up in size, its internal pressure drop is lower. Since keeping pressure drop low is a must for all filter dryers, it makes sense to use as large a filter dryer as space will permit. This is particularly true for the installation of a filter dryer after a burnout. The bigger is better rule is especially true for the cleanup of a system following a compressor burn. Depending on the seriousness of the burn, it will probably require several changes of both the liquid and suction line filter dryers. If the burn was a running burn, meaning the burn occurred while the compressor was pumping refrigerant, then the cleanup will be extensive. It should start with the installation of a special burnout filter dryer in the liquid line. A suction line filter dryer should also be installed in the suction line. Both of these filter dryers should be oversized. It's the suction line filter dryer that will be the determining factor in changing the liquid line filter dryer following a burn. The suction line dryer is changed out until the pressure drop is below acceptable limits. Whenever the suction line dryer is changed, the liquid line dryer should also be changed. If the liquid line filter dryer is not being used as a burnout cleaner, it will be high moisture that determines when it's time to change to a new dryer. The bigger is better rule will apply to a filter dryer where moisture content may be extremely high. Since moisture is best removed at the liquid line location, it may be necessary to use an oversized filter dryer to handle an excessive amount of moisture that may have entered the system. If, even after the installation of an oversized dryer, there is still an indication of excessive moisture, the filter dryer must be replaced until the technician is convinced the system is dry. At the compressor side of the system, the selection process is slightly different. While high moisture will shut down an expansion valve, it is acid and the insoluble contaminants that can kill a compressor. The insoluble contaminants like dirt, metal chips, and sludge. For these reasons, suction filter dryers should be selected more for their filtering and acid removal abilities than their ability to remove moisture. Selection will again depend heavily on the purpose of the installation of the suction line filter dryer. The most common thinking for the use of suction line filter dryers is to use them after a compressor burnout. As with the liquid line dryers, if the filter dryer is to be used to help clean up a burnout, the type of burn must be determined. The severity of the burn will determine the number of change-outs that will be necessary to be sure the system is clean. The dryers selected should be as large as possible and must be replaced as long as their pressure drop exceeds allowable limits. In the case of a standing burn, where contamination has not been pumped out of the compressor, it may not be necessary to replace the first suction line dryer used. If a large enough filter dryer was installed and the measured pressure drop remains low across it, the dryer may be left in the system. One last option remaining in the selection process for filter dryers is the choice between standard sealed filter dryers and replaceable element filter dryers. The replaceable elements provide higher flow capacities and are typically used on larger air conditioning and refrigeration systems. Elements are available that provide for specialized filtering, drying, and acid removal jobs. Special burnout blocks are also available. Standard blocks provide system protection from water and acids in most general-purpose applications. No matter the configuration selected, all filter dryers must be able to remove any and all contamination that is either in a system or might be generated by the system. They must be small enough to fit the job, but big enough to keep removing water and other contamination, and still keep their pressure drop low. And they must be able to keep meeting those requirements long after they are installed. That takes a filter dryer built with special care and chosen because it is special.